basically when you opened up the FluidSIM, then you can start a new schematic here with new, or click File, New. Then you should have a clean sheet of paper. But first, let's start with basic things. Here in the left you have a library. So here the first tab is pneumatic, and if we expand it, then we get actuators, supply elements, directional valves, flow control valves, and so on. Let's start with actuators. Here we see the predefined actuators for pneumatic control, from the most simple ones, single acting, to a bit more different ones, but that's not the question here. To get the symbol onto the schematic, you just have to drag and drop. So let's take single acting and double acting cylinders. And if you want to zoom in on, or zoom out, then press Ctrl and use the mouse rolling part of the mouse. And these are the most simple actuators we use in pneumatic systems. For the first one, the single acting cylinder, there is only one pressure connection port. So if we introduce pressure here, then the cylinder moves out. If we release the pressure, the cylinder will move back in because of the spring here. Actually, it doesn't have to have the spring. It may be returning because of mass when the cylinder is straight up mounting position. And the double acting cylinder here works like when we introduce pressure in one port, cylinder moves out. If we introduce pressure in the other, it moves back in. Of course, we have to release the pressure from the other side too. It has two ports, so they are the input and output holes are called ports here. So we can use pressure to move it in both directions, in and out. Here we can use pressure only to move it out, and it has to return by itself. So if you look at the single acting cylinder and click on it twice, click, we should end up with properties window. In this properties window, the first tab we open is component parameters. Here we can choose the right parameters we are trying to simulate or use in our own system. So basically the program here, FluidSIM, is both for making the schematics for the machine we are building, for example, and also we can simulate the same machine, check if the machine works, if the control system we built works. And here we can also give the exact values of the exact cylinder we are using. Here the default value should be the same value which represents the same cylinders we use in our lab work. So in lab work, our piston diameter is 20 millimeters, rod diameter is 8 millimeters, and the stroke, how far the cylinder will extend, is 50 millimeters. Of course, if we want to use some other values, we can choose them here. Then as drawing properties, it's basically needed if we want to make a symbol bigger or smaller. And then comes the more important part for us, configure the cylinder. So all the components in the library, the actuators, and when we get to directional valves, are predefined in the library. Of course, we can always construct the right symbol for our application here. So let's start with cylinder type. We can choose if it's a single acting cylinder, and the last one is to get a double acting cylinder, as I explained earlier. And then if we're using the single acting cylinder that goes in, of course we have to change on which side the spring is. When we come back to the cylinder type, then where the cylinder body is, we can choose, open this up and choose which kind of or which type of cylinder we are using. If we choose the first one, then it means it's a cylinder without the piston rods. If we choose the third one, then it's a cylinder that has piston rods in both ends. Then comes a two-cylinder package, which is in which both of the cylinders are connected with each other. Cylinder with rods in both ends, and they're connected to each other. And the last one, they're connected to each other from the both ends. So here we're still looking at the pistons. We can choose if our cylinder has cushioning. So we add those rectangles I was talking about earlier and make them adjustable or make them self-adjustable. And last thing we can do in this piston area is to define in which position the cylinder is in the starting moment of the circuit. So always when we draw a circuit, then we show the first starting position. And last thing to do is choose a piston rod. So first one is the most simple one. Second one has a hole through it. Then we have fixing brake systems. We can fix the piston into some kind of exact position. Use them in both ends, and the last one is shows that something moves with the piston rods. Next part is actuating labels. Some later lesson we get to here, but the next thing to look at more detail is the force profile here. Under the force profile, we can choose the right force that is going to be on the cylinder we are using. If the cylinder is under load, for example, some kind of box or some kind of element of the machine is pushing onto the cylinder, we can choose either constant force, external force, for example 100 newtons, or we can apply force profile for the situations where the profile of the force is changing. At first there is no real increase in force, and the force increases in the end of the cycle, or the force is changing throughout the cycle. For the y-axis, the vertical axis, we have the force in Newton meters, or newtons, sorry. And in the x-axis, horizontal axis, we have the from 0 to 50. Here we have the length of the cylinder, so we can choose on which length of the cylinder is which kind of force. And the last tab, external loads. Here we can define the moving mass which is connected to the cylinder, and here we can choose the mass of the thing that is moving and the friction coefficient for the thing that is moving. For example, some kind of thing that pushes packages off a packing line. We can choose predefined values for the coefficients, like steel on steel, cast iron on cast iron, or some way here is tire on asphalt also. Or we can choose the coefficients manually. Okay. To control a cylinder movement in and out, we need directional valves. From the pneumatic chapter, let's expand directional valves. Then configurable valves, mechanically operated, pneumatically operated, and solenoid operated valves open up. At first, let's look at configurable valves. We can also later, when we are building schematics, we can choose from the predefined folders. But for the sake of education, let's use a configurable one. Because as I said, for the cylinders, we can always configure the exact symbol for our valve. And let's take this 3N way valve and put it under the single acting cylinder. So if we are counting the connections, or how to say the valve, then T means 1 connection and arrow means 2 connection, 1 plus 2, 3. And then we look at the boxes, we see 2 boxes, 2 positions, 3, 2. Valve with 3 internal connections and or ports and 2 positions. So I'm quickly just showing that pneumatic control, if the pneumatic control is here, there is a fourth hole we can put a kind of hose or connection to it. One may think that this means 4-2 valve, but it's not correct, because 4-2 valve is this one here. And if we go to the shop or somewhere we want to buy the valve and say we want 4-2 valve, then they're giving the right one here, the actual 4-2. So that's the reason why we don't count in those control element ports. And of course, if I'm using the valve with pneumatic control from both ends, then it has 5 connections, but this is not a 5-2 valve. It's still a 3-2 valve. If we double click on the valve, we get properties as for the cylinder. Here we also can choose the right values for our components, flow rate, for example. Connector labels doesn't have anything at the moment. Drawing properties I'll show later. And configure valve. Here, like in the example of cylinder, we can choose the right components for our valve. And when the valve is controlled only by one thing, one button or one pneumatic air control from one side only, then we put the control element of the symbol to the left side. If it has controllable element on both sides, one button in one side, another in the other side, then we use the symbols on both sides. So here we can choose symbols for left and right. Usually it's on the left symbol. And the symbols are for manually operated. We have a push button, we have fixable push button, we have a bigger button like these red buttons on the tables, fixable. Then we have a lever and pedal. We can use a pedal for controlling the valve, and fixable pedal. Let's take a fixable button later. From the mechanical tab, we can see connections or control elements when we are trying to detect the position of the cylinder. So we have rollers. So when cylinder moves onto the roller, it sends out a signal, and these rollers can be one directional or both directional. And here in the bottom we can see that we have a magnetic position sensor part of this valve. And the last thing to have here is pneumatic or electric control. You can also control the valves electrically. But let's choose the fixable button here. And from below we can check boxes for spring return or piloted valve or pneumatic springs. But it's not a great idea to have this return spring on the left side when we are actuating the same thing from the left side. We have to have the spring return in the other position, so it does return the valve. Because when the spring is on this side, we only push it once and then it will be stuck in the position we pressed. So it has to be able to come back. And from this valve body in the middle, we can choose which kind of connection types this valve has. So at the moment it is normally closed, so in the first position pressure cannot go into the output port, but I can change this. I can flip those boxes around and make another types of connections here, or close all the connections in the middle and make the valve tree valve for. And I can choose the initial position. So okay. When we want to make connections between valves and cylinders or other parts, we just have to come to one of the connections, click on it and just drag it to another connection, and voila, we have a hose here. And the fun part of this program is that we can simulate the situation here. So from the stop, play, start and pause and reset and these controls we can simulate. So when I press start, it gives an error that connections are open and so on. Doesn't matter at the moment. I start the simulation, but nothing happens. I don't have the air supply yet. So what we need to do is go to the supply elements tab, and here we can define the production section of the system quite detailed. But the simplest way to show a pressure output or something, some part of the system where we can take the pressure, is this compressed air supply. That's the most simple one. Connect it to first port, which is in input port always. And everywhere where there are these orange or kind of red-orange circles around, they mean that these connections are still open. Nothing is connected to those connections. So for the third one here, exhaust, when we come to the symbol and it turns green, we can push on it twice and we get the connection dialog. And here from the terminator we can choose how we want to end this connection. We can put the plug on it. We can use straight output to atmosphere, and we can choose a silencer. The valves here in the laboratory all have silencers, so for the correct output here I apply a silencer. Okay. And now if we look at the first schematic, we see there are no open connections left. So the left part of the schematic is complete. And if I start it again, I can see that when I switch the valve, it starts to move. And as I explained, when we switch the tree to valve, we apply pressure, pressure is applied, cylinder moves out, and if I switch the switch back, from the holes 2 and 3, ports 2 and 3 are connected, and the 3 is connected to the atmosphere, so the pressure can come out of the cylinder. Only thing left to do with this schematic actually is to add a way how to control the speed of the cylinder. I'm deleting the connection between cylinder and valve, and I will search for a tab called flow control valves, shut off valves. And here in the up left corner we can see throttle check valve, and will be taking this element. And here we can see this element is kind of strangely large compared to the other symbols. I don't know why. And this is where first time I'm going to use this drawing properties. So if I click twice on the element, the first thing we can see, of course, we can choose the parameters for the valve opening level. For example, how much is it open? When it's 100% open, it doesn't have any effect in the system. But if I have it on 5%, for example, then it starts to affect the speed of the cylinder quite visibly. But drawing properties, here in the scale X and Y, we can choose how big the symbol will be on the schematic. So if it's 1,1, then it's the original size. If we make it smaller, 0.5, we can make it smaller. If we write 2 here, we make it twice as big. So for the logic, I'm using visual logic. I'm using 0.5, 0.5, and press OK, and it becomes twice the size it was, smaller from the size it was. So now it looks better. It looks okay now. At first it was huge, now it's kind of in right dimensions. And the next thing I want to do, I want to rotate it to be in kind of right angle. So to rotate, we click, make a right click on it, and here we can find rotate and rotate it in the direction we need. So I'm at the moment going to rotate it 90 degrees. So this V symbol here is pointed towards the cylinder, and make the connections. Now if I simulate the schematic, I can see that cylinders move a bit slower, and the more I decrease the opening level, so to do it inside of the simulation, we have to just click on the throttle valve, and here we can choose the opening level. We can choose it from the slider, and we can also type it in. So in summary, this is the way how to control or how to make a single acting cylinder move.